Hi everyone.
Good evening, sir.
Good evening. Has everyone joined? Shall we wait for more 2, 3 more minutes? Please check your strength. Has everyone joined? Shall we start? Can you hear me?
Yes, sir.
Yeah. Please make your videos on. Make your videos on.
I'm not able to see any one of you. We'll be just starting in 1 minute. I need to share the PDF. Please switch on your cameras. Everyone. Good. Now I can see a few faces there. All of you do that. Okay. Right. Still, there are people who have not switched on their cameras. Please do that. What is required? Right. So we have to do the topic of free body diagrams, right? Do you know what are free body diagrams? Please switch on your mic and let us have a constructive session. Do you know what is free body diagram?
Yes, sir.
Okay. What is free body diagram? We have to show all the type of forces that are being acted on that particular body, right?
Yes, sir.
Agree? Okay. So free body diagrams, we generally show two types of forces, action and reaction. Agree? We see their action and reaction forces. Yes or no?
Yes, yes, sir.
Right? So we all know that. I'll be starting with a very basic question. Let us say that we have a table, surface table here. Okay. We have a table here. And on the table, we have a body. This is a block. Okay. So what kind of forces do you expect from here, from this figure? What kind of forces do you expect?
Force of gravity and the opposite direction.
What? Pardon? I could not hear that.
Accelerated gravity is the force.
Weight,
acted by gravity.
gravity, force of gravity that will be causing due to the weight. Okay, one weight is there next.
And the
Normal
reaction
force.
Normal force, the reaction of weight, that will be the normal force. So you know that now action and reaction, this gravity, the weight and normal are action reaction forces. Do you know this?
Yes, sir.
Action reaction forces, you know this? So what are the condition of action reaction forces? You know that according to Newton's third law of motion, every action force has got an equal and opposite reaction force. Then why do we consider that? Why to consider two equal and opposite forces? Why do we write that in equations? Can anyone answer that? If they are equal, they are opposite, they are going to be cancelled. So why do we consider them?
Sir, it will be balanced.
I could not understand that. Elaborate. Everyone, whatever you think, you may say. I'm not going to scold you. Everyone, please answer. Whatever you think. Why do we consider action reaction forces in the free body diagrams when we know that they are equal and they are opposite? Why do we consider that? We consider them because they act upon different bodies. They act upon different bodies. You know one thing? The weight of this particular block is going to push this table downwards. So that force will be on the table. And in a reaction, that table is pushing this block upwards with the force N. Did you get that? Yes or no?
Yes, sir.
Yes.
Okay. So they act upon different bodies. That's why we consider them. So the action of body, that is the block, that is the weight, which is acted upon the table. The block is pushing the table downwards due to its weight. In reaction to that, the table is pushing the block upwards. And they are just happening at this particular point, not at this distance. They're just small this point. If I just, sorry, just zoom out that, so it will be something like this. The weight is acted at this point downwards, and the normal is acted at this point upwards. Like this, it happens. That is why we have to consider it. Got it or not?
Yes, sir.
Right? So we'll be starting with a very basic question. Like, you know how to draw the this is the FBD of this particular block. The FBD will be weight acting downwards and normal acting upwards at the surface. Agree? This is the free body diagram of a block kept at a table, just ideally. It is in equilibrium condition. So if this is in equilibrium means what? Net force is zero. Net force is zero. So N, we have to consider a particular direction positive. Let us consider the upward direction positive. So it will be plus N minus weight, that should be zero. So N is equals to weight, or N is equals to mg. This is how we write the equations. You have to consider a particular direction as positive because force is a vector quantity, and the simultaneously other direction will be negative. Are you getting my point? So they ask a statement in the exams, like, is it there that in equilibrium conditions no forces are acting? Is it there in equilibrium conditions no forces are acting? Is this statement correct?
Sir, we have the force of gravity again.
Forces will be acting, but it will be cancelled.
Yeah. Yes, there are different forces acting. But the thing is that what you have to write there, the net force is zero. Okay, in equilibrium, it is not like all the forces are zero. The net force is zero. Whatever force is acting, we have an equal and opposite forces so that we get the net force as zero. Understood? You always remember this statement. These are the basic concepts that is kept behind solving problems. Okay, very basic concepts. Through these concepts only you'll be moving further, and you'll be finding it easy to solve difficult problems. Okay, so net force is zero, right? Let us solve some more problems based on FBD. So let us say that we have a block. We have a block, and another block is kept in attachment with this. This is block A, this is block B. Tell me the forces on block A and block B. Draw FBD. Everyone do this. Please try to focus here. I asked you to switch on your cameras because I need to see whether you're doing or not. But if you don't want to switch on that, I would like to get answers from you.
So the camera is actually very faulty.
Okay, no problem. Do this. Do this. Try to draw the FBDs. FBD, the forces occur everywhere where you have the contact. Forces occur everywhere where you have the contact. This is very interesting topic. I really like this. Sorry. After the sudden change in weather nowadays, I got cold. Do this. Shall I do it now? See there.
Yes, sir.
Weight will be acting downwards. Weight. And in response to weight, you'll be having a normal force N1 upwards. And since there is one more contact at this surface here, so the rightward block will be trying to push it leftwards, N2. If the rightward block is trying to push it leftwards, similarly, the leftward block will also be trying to push it rightwards, N1. And the same weight and the normal, N3. So this action reaction force will be same. So this will be N2 only. This is action reaction force. If the rightward is trying to push it leftwards, same will be the leftward to rightward. So this will be same, rest all will be different. Understood? Did you do this correctly?
Yes, sir.
1 minute. Draw it, everyone. We'll be solving some very good questions today. Done? Shall we move on?
Sir, I have to.
Yeah, go on, go on.
Sir, if the block A is, it has more mass. So shouldn't the force of block B get cancelled out because block A gives more force?
You're not clearly audible. Can you speak a little bit slowly and then elaborate it? I could not hear that.
Sir, block A has more mass. So
Yes.
won't the force applied by block A on block B be greater than the force applied by the block B on block A?
No, 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 no. That was a good question, but no. See, the forces are equal, but the effects are different. You know, whatever force the earth applies to you to pull it towards itself, okay, same force you apply to the earth to pull it towards itself. Do you know that? Do you know this?
No, sir.
Okay, have you studied gravitational forces in your class 9th or 10th?
In 9.
You must have studied. So what is the force acting between two different particles, M1 and M2, kept at a certain distance? Do you remember that?
GMM by R square.
Gm1 M2 by R square. Very good. Okay. So if I want you to tell what is the force on M2 due to M1, will it be same? Yes or no? Force on M2 due to M1. Is this the same?
Yes, sir, I think so.
Right? And if I ask you to write the equation for the force on M1 due to M2, what will you write? M2 into M1 upon R square. Yes or no?
Yes,
Aren't both same?
yes.
But the thing is that the effect of force is different due to the weight. The acceleration produced by this body due to this force will be less because the mass is more. And acceleration produced by this body due to this force will be more because the mass is less. Force is constant, mass into acceleration. If you increase the mass, acceleration will be less. If you decrease the mass, the acceleration will be more. Understood?
Acceleration depends upon mass, not
No, when the force is constant, you have to keep three terms are there. 3 terms are there. Put any one constant and then get if force is constant. If force is constant, so acceleration will be what? Force upon mass. So that means if force is constant, acceleration is inversely proportional to mass. You feel now. You feel one thing. Okay, I'll give you this feeling. You have a fat friend. This is your fat friend. You can think of anyone. And this is you. Okay. What you are doing, you are just running and then collided with him. Will you get back and fall down?
Yes, sir.
Right? And will he fall down?
No.
No. Why? You collided with him. You provided, let us say, 100 Newton of force. And according to Newton's third law, same 100 Newton of force acted upon you also. Yes.
Yes, sir.
But you fell back. He didn't. Why? Because of its weight, more inertia. Inertia is the measure of mass. Understood?
Yes, sir.
Yes, sir.
So that is the thing. It all depends on, I'm just rubbing it out because this is not the topic. Got a feel of it? Good. Right. So we were at the FBD. So now I'll be giving you a question. Now we'll be trying to write the equation from the FBDs. I think you must be knowing how to draw the FBDs by now. So we have 3 blocks here, block 1, block 2, and block 3. 3 blocks here, each of mass M, and M. What we are doing, we are like pushing the first block. This is block A, this is block B, and this is block C. We are pushing the first block rightwards. Okay, rightwards. Sorry. Okay, first what I'm doing, I'm taking it 2 blocks. I'll solve this, I'll show you, and you'll solve for 3 blocks. So what I'm doing, I'm pushing the first block rightwards. What I need to find, the question says that find the contact force. Find the contact force between any two surfaces. Any two surfaces. How many contact forces will be there? Tell me. How many contact forces will be there? Arvind, Nivedita, Vanna, Chitesh, everyone, go on. Tell me anything what you know. Doesn't matter. How many surfaces will be there? Contact surfaces.
Sir, how many contacts it is?
Yeah, how many contact surfaces will be there where we'll be having a normal reaction?
2.
Okay, Vanna says 2. Go on, everyone.
So 3.
3. Arvind, Chitesh, Raghav. Okay.
I think it's 4.
No, 4 is not the 3 is the correct answer. See,
Sir, even I
here
got
is
three.
3. Yeah, that's correct. This is one contact surface where action and reaction force will be there, and the action reaction force will be same. Here, the contact surface will be different because that is the contact between block A and the surface. And here, one more contact will be there. That is the contact between block B and the surface. Understood, everyone? Okay. So if we write the equation for block A, what will it be there? So we have a weight downwards. Okay, that is, let us say mg downwards. In reaction to that, N1 normal upwards and one contact force here to the left, N2. Why? Because see, you are forcing block A to go towards the right. But B wants to remain in their inertia, in its inertia. So it will try to resist. How will it resist? By providing a force against the external force provided. Say yes or no? Yes or no?
Yes, sir. Yes.
Yes.
Understood? But in reaction to the force provided by B, A will say, no, you have to go towards right. So A will cancel that force and it will throw it rightwards. So again here mg downwards and it will be N3 upwards. So now we have to write the equations. The important thing, equations writing, that is most important. So equations can be written one thing. First of all, for writing A, what I am assuming is that both of the blocks are going towards the right with an acceleration A. Both of the blocks are going towards the right with an acceleration A, right? So first thing, for A, what will be writing? Yeah, F force is also there. So rightwards I'm taking positive. Rightwards I'm taking positive, and upward I'm taking positive. So see, if I'm taking the horizontal direction, forces in horizontal direction, that will be plus F minus N2. That will be equals to net mass. That this is the net force, that is mass times acceleration. Yes or no?
Yes,
Plus
sir.
F minus N2 for A only. For A, block A. Now block B. Block B. It will be rightward force is N2 plus N2. Is there any kind of leftward force? Any kind of leftward force? In horizontal direction, any other force for B? No. So that will be equals to mass of B into acceleration, right? Now what we'll do, you have to do it like this. For every question you'll be getting, this is the most simplest one. I'll be adding equation 1 and 2. Adding equation 1 and 2. So what will I be getting? N2 will get cancelled. F is equals to 2ma. Or A is what? F by 2m. This is my acceleration. Now I have to calculate the normal force, the reaction force between the surfaces. So I can put it in this equation. N2 is what? M into A. A, we were not given with the acceleration, we calculated it. So mass into F by 2m. So that is F by 2. That is the normal reaction F N2. F by 2. So F by 2, with this F by 2 force, B is pushing A leftwards and A is pushing B rightwards. Understood or not?
Yes, sir.
If you were to get the horizontal component N1, you could have equated N1 with mg because no vertical movement was there. Any doubt?
Sir, so the F by 2, that what we found out, was it the net force?
No, it is not said to be the net force. F by 2 is the force with which A is pushing B rightwards. This F is not having its direct component on B. So
Okay.
F is transferring some force to A is transferring some force to B. Okay, so this is the force which A is transferring to B, and in reaction to that, we have a net force on A backwards. So that is just a kind of normal force. Now see, this is what you calculated when you saw this in detail. Okay, when you considered A to be a different system body and B to be a different system body. But you know one thing, if you consider this whole system at once, if you consider this whole system, this whole as a system, one system, so what you can consider is that we have a mass of 2m having an external force of F, and that's it. So from there, this 2m is moving some acceleration A, and A is what? F by m, so F by 2m. So that you can calculate directly, and then you can write these equations to get the acceleration. This is one another way that we do. Okay, whenever we try to see the question, see, action reaction forces are when you go into the system because they act on different bodies. But if you combine both of the bodies as one system, so this action and reaction comes under the same thing and they cancel each other. Are you getting my point?
Yes, sir.
Did you understand it or shall I repeat it? Everyone?
No, sir, it is.
Good. So what we did, when we went into the system, we divided object A as different system and object B as different system. Then we saw that there are two different action reaction forces acting on two different bodies. We cannot cancel them because they act on different system of units, right? But when we combined them to make one system, now what happened there? The action reaction came under the same system. They were equal and opposite. We cancelled it out. We did not consider it. What we did, we just considered this 2m mass as just 2m, and we calculated the acceleration. But if they are asking you the question to calculate the normal force, so you cannot use this method. This is only just for calculating the acceleration. Then you have to write these equations. Understood? Is there any problem writing the equations? Anyone?
No.
Good. Written, shall we change the page?
Yes, sir.
Yes, sir.
Right. I really like students like this who like dive into the conversation because that is good. That is required to gain knowledge. Unless and until you ask questions, because every concept has got doubts. Right. So we have 3 block system. This you will be doing by yourself. We have 3 block system. F force is there on the left hand side. All of them has got mass M, M and M. This is block A, this is block B, this is block C. So what you have to do, you have to calculate the ratio of uh, normal forces between surface A and B, or I can write it like between surface AB and BC. So what you have to do, you have to calculate the normal forces at this particular surface here, and you have to calculate the normal forces here, and then you have to find the ratio. So write the equation, you draw the FBD of each block, write the equation, and then you calculate the forces. Do that. Is it done?
I don't know if it's correct.
What did you get? No problem. Whether it is correct or not, you should go on, because this is not a test. This is just a practice.
With 3:1.
How much?
3:1.
3:1. This is one answer we have got. Any more answers? All of you solve this. Nivedita?
Doing, sir.
Okay, Vandana? Jitesh?
1 minute, sir.
Doing so.
Raghav? Kavya? Ashwin? Amrisha? You're not saying anything. Why are you mute? Shweta? Actually, I cannot see you because you are lying below in the table. You need to speak, otherwise it won't be beneficial for you. I'll be waiting for 2 more minutes. Shall I do it now?
Yes, sir.
Anybody near the answer? Okay, I'm doing it now. See, first what we'll be doing, everybody look up here. First we'll be writing the FBD. So this is block A, M, this is block B, okay, M, and this is block C. M and C, right? So forces, first one will be the weight, mg downwards in all of the cases, mg downwards, and then again mg downwards, right? Force here, rightwards, and in reaction to that, we have one normal force leftward, N1, and same normal force will be rightward here, N1, okay? In one contact, we have same normal force. In response to this, we have another normal force, let's say N2. Here we have N3, and here we have N4, right? Now we have got one more. What color should I use? Is this working here? No. Okay. Yeah. So here we have got one more contact surface between B and C. So that has got the value. C will push B leftwards N5, and B will push C rightwards N5. First, tell me anybody who came up till here, who matched till here.
Sir,
You got it? Good. So now
Even
we'll be
I-
writing the equations for A, because we are considered with the horizontal movement, vertical movements are cancelling each other. That's why we are not considered about that. If vertical movements are cancelling each other, that means N2 directly is equals to mg, N3 is directly equals to mg, N4 directly equals to mg, like that. Okay, so we'll be just considering the horizontal movement. So I'm assuming that this is going with an acceleration A. So two ways are there. Either I can consider the whole system as one. So in that case, what will be my acceleration? Acceleration will be f by 3m. But I'll be going with the equations, right? So first of all, I'll be considering the rightward positive and upward positive. So rightward plus f minus n1 is equals to m times a. Say yes or no.
Yes, sir.
Right? Nivita, tell me this equation for
yes,
B.
sir.
Tell me the equation for B. See, n1 forces, n5 forces are there horizontally. Tell me the equation.
Sir, plus N1 minus N5 is equal to MA.
Good. Vandana, third equation.
Sir, N5 is equal to MA.
N5 is equals to MA. Everybody agree with this? Right? Everybody agree with this?
Yes, sir.
Good, good. Now, see, if I add all of them, this is equation 1, this is equation 2, this is equation 3. If I add all of them, add 1, 2, and 3, what will I be getting? Won't I be getting F is equals to 3MA? And from there, I can calculate A is equals to F by 3M. Right?
Yes, sir.
Okay. So I need two things. What is the contact force between A and B and B and C? What is the contact force between A and B and B and C? Tell me which representation they are talking about. Which ratio I need to find? What is the ratio I need to find? Tell me. Go on fast. Of what ratio we have to get the answer? Contact force between AB and contact force between BC. What is that?
Equation 1 divided by equation 2 for AB.
No, like not like that. Which term here they are finding? Which term here in this the FBD? What is the contact force between surface A and B we have done here? We have represented here. Contact force between A and B. What is the contact force between A and B?
N1.
N1 is the contact force between A and B. That's correct. Why are you getting so confused? And what is the contact force between B and C?
N5.
N5. It's easy. So we need to find the ratio of N1 and N5. N1 by N5. Say yes or no.
Yes, sir.
Everyone, fine with it?
Yes, sir.
Okay. So we can calculate N5 directly from here by putting in equation 3. So N5 is equals to MA. A we know, M times F by 3M. So it will be N5 is F by 3. Agree?
Yes, sir.
Right? And what is N1? Put in any of these two equations and get me N1, everyone. Do it fast. Put in any of these two equations the value of A or the value of N5, you already know, and get me the value of N1. This is really easy. You just don't have to do any calculation errors.
Two by 3F.
2F/3.
Good, good, good. Kavya, good. And who said the next one?
Sir.
Nivedita, good. So N1, if you put in any of these two equations, you'll get N1 as 2 by 3. N1 is equal to 2F by 3. Shall I do it for everyone or you all got it? Arvind, Chitesh,
Got it.
Yes, sir. I got it.
got it?
Yes, sir.
No, sir, working.
Shall I do it for you?
Yes, sir.
Like say here, if you put this in equation 1, F minus N1 that we don't know M into, instead of A, I'll be writing F by 3M. So N1 you'll get F minus F by 3, that is 2F by 3. Even if you put here the value of N5 F by 3 from here and acceleration F by 3M, you'll get the same thing. Understood? Got it, Chitesh?
Yes, sir.
Okay. Now the ratio N1 is to N5 is what? 2F by 3 divided by F by 3. So you'll get 2 by 1. N1 is to N5. Understood?
Yes, sir.
Everyone, write it down. We'll be changing the page.
Yes.
I hope you are all liking it and understanding too.
Yes, sir.
Good. Shall I change the page?
Yes, sir.
Everyone?
Yes,
Right.
sir.
Yes, sir.
Good. Now we'll be seeing something new. These were the basic one where you just had the concept of horizontal forces. Now what we have kept. Now physics and math is something to create problems. If you find something easy, they will create some difficult problem than that. So what they do after creating problems horizontally, they found that the students are easily able to solve this. They kept the block on a wedge, an inclined wedge. Now you have to calculate the free body diagram. So once you understand how to draw the or how to write the forces in this particular case, so after that you'll be finding it easy to do this. Okay. So how to do that? First of all, see, acceleration due to gravity always act along perpendicular to the surface of the earth. So that will be like this, straight from the center. This is mg. Say yes or no. Yes or no.
Yes, sir.
Right. Now let us say that this is at an angle of what this angle is. Anybody tell me what this angle is? Or if I draw this more in a detailed manner, I should do it in a bigger way. Let's take shapes. Right. Sorry. This is a wedge. On this wedge, we have kept a block. This wedge is at an angle theta. Now what we're doing? This wedge,
Yes, sir.
the weight will be acting perpendicularly downwards, mg, right? And let us assume that this is the horizontal now, new horizontal, and this is the new perpendicular. This is the new horizontal and this is the new perpendicular. So if this is the angle theta, can I say this is 90 minus theta?
Yes, sir.
Everyone,
Yes, sir.
right? So if this is 90 minus theta, this will again be theta. This will again be theta.
Yes, sir.
I need to change this shape color, otherwise it will be a problem. This is fine. No, I think this is fine. Okay, this is theta. Agree? So if this is mg, can I write the horizontal component as mg cos theta here? Can I write the horizontal component as mg cos theta here? Because whatever we have with the theta, the component along it is cos theta. Do you know that?
Yes, sir.
Everyone, tell me.
Yes, sir.
If you understood this, you'll be able to solve any type of question based on this. But if you did not, then it will be difficult for you. So whatever doubt you are having, just clear it out right now. So can I write it as mg cos theta here? Yes or no? Right?
Yes, sir.
Okay. And what this component will be? This component of weight?
Please, thank you.
Good. It will be mg cos 90 minus theta, because this angle is 90 minus theta. You can write it as mg or mg sine theta. Agree? Now there will be a normal force, na? Because there is a surface here. there will be a normal force upward like this from here, from this surface N. Yes.
Yes, sir.
So now these are all the forces acting on this particular body. So what force is causing the body to slide down the wedge? What force is there which is acting on this particular body so that it slides down the wedge?
So friction.
Oh, how friction is coming to picture? I did not introduce friction here. See the diagram.
Gravitational force.
This is the sine component of its weight. This is the force that is taking it downwards, isn't it? Yes or no?
No, sir.
Got it or not? Is there any doubt?
No, sir.
Good. So what acceleration will be there? Acceleration will be, so net force in the inclined portion of the wedge, because this is moving. We have assumed our coordinate system like this now. We are assumed our coordinate system like this. So in the horizontal component of the new coordinate system, the acceleration that is acting is just due to this force mg sine theta. So this acceleration that is taking it downwards is g sine theta. And the normal force will be mg cos theta. Do you understand this? Yes or no? Do you understand this?
Yes, sir.
This is very unique theory there. Understood, everyone? Right? Okay. Okay. Draw this out. Draw this. Everyone draw this and let me know if you're done.
Sir.
Done, everyone? Tell me when it is done. Is it done? Shall we change the page?
Yes, sir.
Okay. Anybody need time? Right. So last question for today. Question is, on an inclined plane, angle theta is 30 degree. The weight of the block is 5 kg. What force is required to move it upwards with an acceleration of 2 meter per second square? What force is required to move this block upwards with an acceleration of 2 meter per second square? Do it quickly, as fast as you can.
So to move upwards with that acceleration.
To move upwards with an acceleration of 2 meter per second square. Draw the FBD, write the equation.
So 35 Newton.
35 Newton. I don't know this. I just have created this answer. So I'll see it at the end. 35 Newton. Now, time is good. You should be this quick, but I don't know the answer. I'll check it right now. One more minute and then I'll start solving. Okay. Now see, for this particular inclined block, the weight will be acting like this, 5g. And as we know that this will be the angle theta. This will be the angle theta, and this is 90 minus theta. We know this. So normal to the weight, so normal to the block, normal to the inclined plane, it is 5g cos theta, and inclined plane it is 5g sin theta. So we need to provide an external force in this particular direction, like this, F. Okay, because this is trying to slide down like this with the force of 5g sin theta, and we need to provide it an force F so that it moves with an acceleration 2 meter per second square upwards this way. So what I have done, I have assumed my coordinate system to be like this. Okay. The observer is free to like make its own coordinate system in whichever way he wants. But the thing is that you need to express everything according to that only. So I'm the upper direction as positive, downward as negative. Tell me the equation, Arvind.
Sir, for the downward
For
force.
this condition, see, there will be a horizontal normal force, and this because there is no net movement in the vertical direction, so n will be equals to 5g cos theta. That we don't have to equate. We have to equate the net movement in the horizontal direction along the wedge. So tell me the equation that you'll be creating along this horizontal direction. Nivedita, you go on.
Sir, negative 5g sin theta.
Negative 5g sin theta. Then
Equal to mass into.
no, we have to provide a force also, na, plus F along the upward direction.
So F minus 5g sin theta is equal to ma.
This is correct. This is correct. Everybody agree with this?
Yes, sir.
Good. So minus 5g sin theta plus F is equals to 5 times A. A we already know. Minus 550, 510. Let us consider G as 10 sin theta. Sin 30. What is sin 30?
1/2.
1/2.
1 by 2 plus F is equals to 5 into 2. So minus 25 plus F is 10. F will be 10 plus 25. That is 35 newtons. So this is the correct answer. Good. Kavya. Very good. So everybody understood it? Got
Yes.
it? Good. Now will you be able to write the FBDs easily? Say yes or no?
Yes, sir.
Yes, sir.
Good. Vandana, understood?
Yes, sir.
Chitesh, any doubt there?
No, sir.
Nivedita, any doubt?
No, sir.
All of you? More are there. Shweta, Ananya, you're not saying anything. Are you even there? Ashwin,
Yes, sir.
Yes, sir.
any doubt? Raghav, Amrisha?
No doubt, sir.
Good, good. So shall I stop sharing now? Do we have another class for maths?
Yes, sir.
Yes, sir.
Okay, so just join after 5 minutes, 5 minutes break, and I'll be there. Okay
Okay.
then?
Okay, sir.